Think of Neptune, and you probably picture a quiet, frozen sphere sitting motionless in the dark. But the edge of our solar system is not a tranquil place. It is a highly active, chaotic engine, and Neptune has been driving that chaos from the very beginning. To understand how it got this way, we look at the Nice model. Originally, Jupiter, Saturn, Uranus, and Neptune were tightly clustered near the Sun. Then, roughly 4 billion years ago, a massive gravitational instability forced the gas giants to rapidly migrate outward. Neptune was thrown the furthest. Acting like a massive cosmic bowling ball, the giant planet plowed outward into a dense primordial ring of ice and rock that surrounded the early solar system. That primordial ring of debris is what we now call the Kuiper Belt. Neptune's sheer mass and momentum carved a path right through it, scattering trillions of icy bodies, comets, and dwarf planets into deep space. Tearing through that dense field of material, Neptune shaped the architecture of the outer solar system. It established itself as a massive gravitational disruptor, a role it continues to play today. As Neptune violently displaced the Kuiper Belt, its gravity ensnared a massive, independent dwarf planet. We know this captured world today as Triton. Looking at this high-resolution image of Triton's south pole, you see evidence of its separate origin. Instead of a uniform crust, it's covered in dimpled, wrinkled ridges called cantaloupe terrain, the result of extreme geological stress, unique compared to Neptune's other moons. The clearest proof of Triton's capture is in its mechanics. This orbital model shows Triton locked in a retrograde orbit. It revolves in the exact opposite direction of Neptune's own rotation. Out of all the large moons in the solar system, Triton is the only one flying backwards against the current. A dwarf planet crashing into Neptune's orbit, traveling the wrong way, had devastating consequences. Triton's chaotic arrival likely resulted in massive collisions, shattering most of Neptune's original moons and leaving the giant to rule over a heavily battered system. Today, Neptune sits 30 times further from the Sun than Earth. At that distance, high noon on the surface looks like dim twilight to the human eye. Yet looking at this cross-section of the planet's interior reveals a thermodynamic mystery. Despite existing in a deep freeze, Neptune actively radiates 2.6 times more energy from its core than it receives from the Sun. This intense internal heat rises through deep layers of pressurized liquid water and ammonia, eventually colliding with the frigid upper atmosphere. The extreme temperature difference creates an active pressure cooker, driving winds at speeds exceeding 2,100 kilometers per hour. While its neighbor Uranus is largely dormant, Neptune uses the leftover heat from its chaotic formation to operate as a self-powered engine, generating the fastest sustained winds in the solar system. Descending into the troposphere, the reality of those winds becomes clear. The atmosphere is a churning mix of hydrogen sulfide and ammonia, ripped apart by supersonic currents that drag frozen methane ice crystals across the sky. These violent currents frequently tear massive holes in the planet's cloud deck. This photograph captures one of these events, an anticyclonic storm known as a Great Dark Spot. It is an immense, high-pressure elliptical vortex bordered by bright white cirrus clouds made of frozen methane. Unlike the Great Red Spot on Jupiter, which has churned for centuries, Neptune's dark spots are highly transient. They are temporary voids in the methane deck that open up, shift latitudes, and completely dissipate over a few short years. The fleeting, intense nature of these storms perfectly captures Neptune's environment. It is an atmosphere in constant overdrive, where structures are rapidly built and destroyed by sheer kinetic energy. Neptune's violent chronology is far from over. Triton's retrograde orbit, the very motion that proves it was captured, is also a death sentence. By flying against Neptune's rotational momentum, the Moon experiences constant gravitational drag. This creates tidal friction. The gravitational pull between the two bodies continuously saps Triton of its orbital energy, forcing its path to Titan. With every single lap, the Moon is spiraling inward, inching closer to Neptune's dense atmosphere. It is a slow, methodical process, but the physics guarantee that Triton will eventually pass a fatal threshold. About 3.6 billion years from now, Triton will cross the Roche limit. At this precise distance, Neptune's gravitational pull on Triton's near side will overpower the gravity holding the Moon together. The immense tidal stress will physically stretch the Moon, cracking the crust and peeling chunks of rock away into the void. The structural failure will be absolute. Triton will be shredded into trillions of icy fragments, instantly transforming a solid world into a massive debris field. The kinetic momentum of those fragments will quickly flatten them out around the equator. Neptune will preside over a graveyard of its own creation, wearing the shattered remains of its captured moon as a brilliant, sprawling ring system. Long after the sun has begun to exhaust its fuel, Neptune will remain the cold, high-energy monarch of the outer solar system, ruling over a world forged and finished in violence.